Classification of decimal numbers. Decimal expansion is classified into terminating and non-terminating. The non-terminating is further classified into repeating and non-repeating. Let us discuss each in detail. Let us know in detail about terminating decimals. The word terminate means end. A decimal that ends is a terminating decimal. In other words, a terminating decimal has a finite number of digits after the decimal point. Click each tab to know more. Let x be a rational number whose decimal expansion is terminating. Then x can be expressed in the form of p by q, where p, q are co-prime and the prime factorization of q is of the form 2 power n, 5 power m, where n, m are non-negative integers. Some of the decimal numbers expressed in p by q form are as shown on screen. By expanding this number further in the form of p by q, we get as follows. That is, writing the numerator and denominator in terms of the product of primes, we get as shown. Similarly, the terminating decimals 1.04 and 12.5 are expressed as follows. Any rational number that has a decimal expansion which terminates is expressed as a rational number whose denominator is a power of 10, where 2 and 5 are the only prime factors of 10. Therefore, during the simplification of rational number, we observe that the number is in the form of p by q, where the prime factorization is in the form of 2 power n, 5 power m and nm are non-negative integers. Let x is equal to p by q be a rational number, such that the prime factorization of q is of the form 2 power n, 5 power m, where n, m are non-negative integers. Then x has a decimal expansion which terminates. For example, the rational number 26 by 25 is expressed as 26 by 5 square. Now the prime for both the numerator and the denominator are as shown. Thus by further solving, we get as 1.04. Similarly, the expansions of the other two rational numbers are as shown on screen. Now, let us solve an example problem on this theorem. The word non-terminate means never end. A decimal that never ends is a non-terminating decimal. Let us solve a few example problems on non-terminating decimals. For example, let us consider decimal conversion of 1 by 7, which is non-terminating and recurring decimal. By further solving, we can see that the decimal never ends and the remainders are not repeating. But as the quotient is repeating itself, it is denoted by a bar. Since denominator is 7, which is not of the type 2 power n, 5 power m. Let us consider one more example. Here, when the dividend 10 is divided by divisor 3, the remainder repeats itself. Also, a decimal number in the quotient repeats itself without termination. In this example, as 3 is repeating itself, hence it is non-terminating decimal. So, from the above two examples, let us state a theorem. Let x is equal to p by q be a rational number, such that the prime factorization of q is not of the form 2 power n, 5 power m, where n, m are non-negative integers. Then x has a decimal expansion which is non-terminating, repeating. Example 3. Using the above theorems, without actual division, state whether the following rational numbers are terminating or non-terminating, repeating decimals. Solution. By the theorem, let x is equal to p by q be a rational number, such that the prime factorization of q is not of the form 2 power n, 5 power m, where n, m are non-negative integers. Then x has a decimal expansion which is non-terminating, repeating or recurring. Thus, by solving all the given rational numbers, we get as follows. Example 4. Write the decimal expansion of the following rational numbers without actual division. The decimal expansion of the following rational numbers is as follows.